Hello everyone, good evening. Good evening and welcome to day 17 of our AI with NVIDIA masterclass. Welcome you all to this session. Good evening, am I audible? Can you guys see my screen? We'll wait for a couple of minutes for others also to join and then we start our session on image segmentation on today's class. So you can post down what is image segmentation in chat box. If you guys are aware of its applications, you can also post that as well. Yes, tell me in chat box what are some applications which you know about image segmentation. Any idea about some models? Good evening all. So today's session is particularly going to be a topic which is called as image segmentation. So we have seen mostly about classification. Yesterday we have seen about object detection, and in this session we are going to also discuss about a topic which is called as object segmentation. Okay, so how many of you guys know that recently Facebook has released something in the name of SAM? Have you guys heard or used that by Meta AI? They have released a model which is called as SAM, and the full form or the abbreviation also they have given with it is SAM, segment anything. Okay, so that's the keyword which they have given. So it is a particular tool which is available for you for your demo as well. So that's what the image segmentation is also going to do. It's one of the powerful open source model right now they have. For example, let us go for search. You can also do the search SAM segment anything. So this segmentanything.com. Okay, so segment anything model, that's why it is called as SAM. You can go inside and then you can try to read about it. As you can see, it is doing this segmentation. It is selecting a particular object alone. Okay, especially earlier we have went for image classification between one class to other. Okay, and then we have yesterday's class we have discussed about object detection. So if it is in a frame, it is just going to give you a bounding box. But this segmentation is something like it will select only the pixels of that particular boundary and have that alone as well. So this is one of the high-end model. You can't achieve this at the beginning itself. It's somewhat very equal to our GPTs. Okay, but anyway, we'll see this to understand how the segmentation actually works. See here, this is a demo of a particular all the kitchen items, all these cutleries have been segmented. Which can automatically do a lot of progress, right? So you can see we can do the zero shot generalization. So we can actually try with our own data, our own image as well. You can use this. They are also providing you link for the download data set as well. So this has been trained on nearly 1.1 billion segmentation mask collected. Okay, so it's a huge amount of data set which has been trained. Okay, so with the help of GPU, as you can see the image, GPU embedding, so it's similar to somewhat a transformer architecture for image. So you can try this, try the demo. You have to actually accept the conditions, and you can either select one of these images or you can upload your own image as well. So let me go into this image. You can also yes, Sam is segment anything model, Sam. So you can upload anything, and then what you can do is you can just hover over and then try to select, or what you can also do is you can add a mask. For example, let us select the pitch alone. So as you can see now, it is highlighting and showing you the pitch area alone, right? For example, I also want this particular player. Okay, so you are selecting the humans as well now. So this is how you can actually select and then make use of it. It seems it's just a demo of how you can actually do, or you can also draw a box, it seems. So you can, when you draw a box, it will segment objects which is inside of it, and you can also go for everything. It seems it's not available for us in free, so that something like it is going to select all the points. So this is the cutouts which you can anyway prefer. So this is, as you can see, it is getting you the boundaries, right? So this you can manually do. For example, you can use canny thresholding techniques to detect the edges, and then you can do the same process as we did earlier with OpenCV. So this is a high-end tool. Maybe we'll once again use this with some other image and then go into the actual content of this session. Good evening all, very good evening. Hello guys, am I audible? Am I audible everyone? Is my internet connection clear for you guys? So first it has to actually extract the information, which is the embedding information out of this image, so that it is given to its this model, and it can be able to give you the respective result. So this embedding is what makes it easier for it to work actually. So I think it is taking a lot of time. Maybe we will keep it of this particular session. So this is the task we are interested in. So image segmentation, a topic of day 17. So image segmentation is a computer vision technique that assigns a label to every pixel in an image, such as the pixel with the same label shares certain characteristics. For example, in a street scene, all pixels belong to car might be labeled with one color, while those belonging to the road might be labeled as another color. So maybe road can be given a single color, objects or cars or vehicles can be given other color, people can be given with other color. This can be done. Okay, so this is what we call it as image segmentation. Where you have an image, you are going to all these pixels. You can either leave it and then focus on only your object, or you can also do semantic segmentation, like all of these pixels should now belong to any one class. So what you do is, the background you are giving some yellow color, the road you are giving some pink color, the vehicles are given red color, and then the trees are given green color, and the sky is given blue color. So all these pixels, okay, so this pixel must be either to this one or this one, so it has to be done in image segmentation. So the core task of image segmentation is to classify each pixel, okay, in an image. So you have an image, it should classify and then decide. For it is used in lot of applications. Can you guys post some of the applications in chat box where this image segmentation could be of, some of the applications in chat box where this image segmentation could be of great play? Any idea? Any idea about it? So looking at the applications, we have applications in biomedical image analysis. So actually, to make medical diagnosis, radiologists need to interpret a variety of charts and photographs, right? It is difficult for medical photographs with many overlapping configurations can make diagnosis difficult even for qualified specialists. So segmentation is actually scan reports, photographs, for example, this Scopy and all those things where we are taking images inside and then check for polyps or any other particular diseases or any abnormal growth or any symptoms in it from the result. You can actually use image segmentation to highlight it so that you could understand. So that even a professional who are facing difficulties can use this to overcome and make better solutions out of it. And yes, very good. Autonomous vehicle. So autonomous driving is an incredibly complex activity. As you know, it involves awareness, enterprise, regions such as road lanes and sidewalks and all. So the segmentation of instance is used in autonomous driving as it is important to track individual vehicles, pedestrians, signs and all, etc. So if, for example, if you are looking at the vision of a particular car, okay, so you need to understand what all the particular road, what all areas are available, what car, whether if it is a car is there, you don't want to take that path, okay, traffics, okay, so it is used in lot of places. Apart from that, you also use it in satellite image processing, where the aerial or satellite images cover a vast area of land and include a number of artifacts. Sophisticated image annotation is required to perform accurate analysis on aerial or satellite images, and semantic segmentation has applied application in precision farming and geosensing and all. You can use it to map and then analyze the heat and all these progress. So these are some of the applications, and looking at the particular example we will be seeing today is Yes, I'm audible now, guys. Some internet issues. I hope it is clear now. So our data set is going to do the road segmentation so that you find in your environment, you find the empty place for your car to travel. So it is going to segment the road. If it has object, it has to avoid it. Okay, so that's our entire task of this session. So also we would be using a VGG model. We know how VGG works, but for this image segmentation, you guys need to think and tell me answer. For image classification, we are doing S or no, which we can do 0 or 1, like following the machine learning principles. For object detection, we have went with YOLO models, or those models again a CNN based model where the classes have been given with probability as well as the bounding box information. X1, Y1 and X2, Y2 is also trained, so that over the time when they train and they make prediction, they are going to give you the particular pixel value where this starting and ending point of the rectangle of that particular class should be. So this is done. But when it goes for image segmentation, our input is image and the output is also should be image. You guys can understand it, right? Can you understand? The input is an image and then the output generated is also going to be an image. It is not the same case as we have done with object detection or image classification. So there the task is different. Here you want to segment it. Also anyway, the result is going to be an image, not S or no, or just the X1, Y1 and X2, Y2 value along with the predicted class, so that you can just annotate with OpenCV. This is not done in that way. So you will be getting a particular result as an image output as well, which you have to work with it. So the core task of image segmentation is to classify each pixel in an image. So for understanding this entire progress, we will teach you about UNet architecture. So let me just give you a glimpse of UNet, which we won't be using much here. We won't be using, but this is a base model which is used for a lot of applications in it. So before continuing, you can still convert the masterclass into 1 month certified internship on NVIDIA with AI. And when you join, you will be getting 30 days of recorded sessions, 30 days of PPT, exclusive project codes, VIP community group for doubts and internship updates, IETE internship confirmation letter, 90 days of LMS course access, assignments and tasks, weekly live sessions, resume building and mock tests, internship and participation certificates. All these things you could get it at a discounted fee at just 999, and tomorrow is going to be the last day. Today one day is there, tomorrow one day is there. Tomorrow is the last date. If you guys still interested, batch 3 ends by tomorrow, which is 3rd. You can register still and get all these benefits. The discounted fee is just 999. You can register and get all the benefits. The registration link is posted in chat box. So let us see about UNet. What is this UNet architecture? As the name itself suggesting, it is something like a U-shaped net. Okay. For example, UNet is a convolutional neural network architecture designed for semantic segmentation task. So its name is derived its U-shaped architecture, which consists of a contracting path like a encoder followed by an expansive path which is decoder. So this unique structure allows UNet to capture context at a different scale while maintaining spatial information as well. For example, this is how the UNet will work. You have an image, your output is also going to be an image, so it is contracted and then it is enlarged. So first it is contracted, then the information will be transferred from here to here using skip connections. Remember skip connection, x plus f of x. So this from here to here, the information is passed. From here to here it is passed, so that it will still get the original image with some modifications, and that modification is what we are expecting like this. You need to still maintain the structural integrity, but only the segmentation which you are performing, you want to give that idea to the model. So that's how UNet works. For example, see here, what it actually does is you consider you have an image shape of 512, 512 cross 3. So you apply convolution layer, convolution pooling, max pooling and all. See here it is a convolution 3 cross 3 ReLU. Same padding layer is done. So when you do it, when you apply the formula, you know that the size of the image decreases, right? So we have applied that formula. You can also manually apply. When you create a model, you have to manually apply, because you have to calculate. They have to be same, they have to match. So what you do is you will be applying convolution and max pooling. So the size of your image will be keep on decreasing. At one point of time it will be converted to a single dimensional array like this, 1024 elements. So once you reach that stage, it is going to upscale now. So there is something known as upscaling or convolution transpose 2D is available, upscaling 2D is available. So what they does is they get a smaller size image, they upscale or upconvert it to higher size image, then higher size image, then higher size. So when they perform this operation, you will be getting back your image size here. Also what you can see is you can see this copy, or this is called a skip connection from one to another, right? So from this layer to this layer, from this to this, from this to this, from this to this, the parallel layers have been connected, and the reason is here there will be a feature after passing that won't be having that, so you will be passing from here as well. So they have to mix and train so that you can perform a segmentation like this, because most of the information you want to transform from the original image, only the segmentation should be done, and for that process the UNet or other algorithms, like for example whatever algorithm you do, you can take pre-trained model, you can build it from your scratch or anything. You can build UNet from your scratch. Actually, I have to just calculate how much the size decreases, and for upscaling there are formulas. You have to find how much the size increases, so that finally they should match, so that you can go for loss function, intersection over union and all. So with these things, what we will be doing is, again, so here this is UNet. You can take a pre-trained model as well, like VGG16 or MobileNet. They have their segmentation task. So as usual, we know that we will free some layer and we take a part of it, and then what we are going to do is, in that we will be stacking few more layer, which further convolutes and then make it like a single dimension. At the same time, you want to also add skip connections, then finally you want to upscale it as well, like you have it in UNet. So you will be upscaling the sample, downscaling, and then finally upscaling to get back the result as a shape of your image as well. so that if you resize and work and then compare the loss function, you can able to train a model which does this task based. So are we clear with this introduction? Can we go and see the hands-on code of this particular process? We have a trained model as well that we will be seeing how to work, how it is working and all we will be exploring now. Before that, can we start? Yes, are we clear? So now we go into hands-on to look at the particular progress. Okay, so I'm going to, before that, let us try to segment this, and I want to check how well this works. Okay, you can even select a particular vegetable. Irrespective of the sunshade and all, it is able to, okay, these are together. These you can separate. Let us go for cutouts. Okay, fine. So for this task we are going to use Kaggle notebook, and the reason is the memory. Okay, so my system here, it doesn't have that much size. Anyway, for training, this is not the laptop is not a great environment. The RAM will be completely gone. Okay, memory out of memory error will come, and the training will be stops in between or it won't even start. So if you look other ways like Collab and all, they also have the same problem. They give you limited memory. When you go for here like Kaggle and all, you can use a GPU. Okay, and then if you turn on, you get lot of memory as well, which is for RAM and GPU. So your model, this project can actually run. And we are importing all the required, like usually you can go with a pre-trained model. This is also a combination of pre-trained, fine-tuning. So we go with layers like convolution 2D, max pooling 2D, and then we have upsampling 2D, then concatenate to for that skip connection to combine. Okay, so convolution transpose 2D is actually used for upscaling with. So these are some of the layers which we'll be using, and the model we will be using is VGG16 model. And these are some of the supporting TensorFlow importation. So here is the memory part, which gives you a lot of disk memory, RAM memory of 30 GB, GPU memory of 15 GB, 30 hours of free GPU for you, so that you could train your model here very well. So the dataset we are going to use is a dataset called as Kitty Road Segmentation dataset. You have a training dataset and a testing dataset. So if you go inside, okay, so this is the segmented road actually. So original image will be you will be having it in the, for example, so this is the original road. As you can see here, out of this, only that particular road which is available for travel is segmented. So that is, this is your input, that's your output. That's how we train our model, right? So the target here is going to be this particular one. Which will be something like this, which is going to tell you that where the particular road is available. Okay, so it will be just giving you this particular locations of it, so that you can train and then inference, and then you can fine tune it as well. So we are loading the data sets and looking at the number of samples. Okay, so the total number of training samples is 231. As you know, we are going for trained model because the data set size is also limited for us. For validation we have 28, and for testing we have 30. So the common fixed size 128 is the image size we are going to keep. The number of channel is 3, number of classes is 1. You want to just detect only road. You can also have multiple classes here. So when you go for multiple classes, multiple object will be detected. Here I want to just classify the road and segment it, so we go with 1. So this is just the image parser. It's a particular code for using TensorFlow to read the file, decode and convert the data types. Okay, just rename them and then like save it. You have to like it is added to a particular dictionary with image and the respective segmentation mask. Both are commonly done here, and this will give you the entire size, the information. You can go and map actually. So this will apply this particular parse image. It will take all the data set inside. So once you have it, the process starts. Okay, so it will just pick some part of your training and validation size, then it will skip the train set size. It will take the train set size and then skip from this. So you just do this mix match. And there is something known as a TensorFlow function is available. You have to use the decorator. So those who know about Python in depth, you know about decorators. They modify the way how a particular function works. So we have a function which usually if you do some process, it will give you a result. These are mostly the data type which is native to the Python. When you go and give it as a TF function, TensorFlow function, you are actually telling that it is a function belonging to TensorFlow. So that decorators are actually used to modify the process of this function, and what they modify actually here is they modify the performance here. The result will be a TensorFlow operation result, like the tensors will be given as output. So you are having it for normalizing, loading image, training data, and loading test image. So both are available. We are just doing some random transformation like flip. Some of them are flip left right. This has been done for image and mask, because you want to give variety, because the road will also be same like this 230 images. We have different variations of road, and again if you have more data set, if you train furthermore, it will be really great. So this is the batch size. The batch size is actually 32 and the buffer size is 1000. So the data set where we are going to give it as the training data set, validation and test data set inside data set. So all the training data is mapped to use this load image train, and this is done with auto tune. So that will help you to efficiently process this entire data. So that is auto tune from TensorFlow. Then we are doing some random shuffling. Then we are repeating it multiple times, so that every time you pick you get different shuffle. Then you are adding the batch size. Then prefetch is done. This is again to fine tune the performance of it. So this is done for the validation data as well as test data. So finally you have this set of train and all. So I have to run this and then run the next one. Yeah, so this is the entire combination it has done. So now we are going to display a sample image which we have. Okay, so this is matplotlib code to display the image as well as the output respective with it, like respective. So let us see the first image and its output. I hope you guys can see. This is what the input image, your road from your camera going to look. This is what the output we are expecting. We are expecting to have it in this place, like the road alone. For example, let us go for the 10 we have. We'll look at it. Okay, so this is the training data actually looks. So here you can see the road is available in this place, and here and all you have vehicles. You can't have that, right? So you can't mark that. You have to leave that space and mark here. So that's what done here. So this we will also check whether it is working in the respective way or not, as we expect we'll be doing now. So now going into the model. So the model is VGG16. As you know, it is called a visual geometry group. It's a model with 16 totally convolution layers and max pooling layers, right? This is the summary of it. So from here we are going to add additional layers. Okay, so we are going to choose include top equal to false, weight says ImageNet. Okay, so we are going to first get the convolution layer, some convolution layer like block 3, pool 4 and 5, because we want to do this concatenate, which is the skip connection as we had with the unit, right? So you are picking some of the layers from this side, you are picking some of the layers, so you can do this connection, and that is done in concatenate. So what we do is the upsampling. So once the end is done, you are going to upsample, and the interpolation is bilinear. So here C3 is done, and then what it does is it is concatenated. Okay, so this U1 along with the C2 is concatenated. Then the same thing is applied for U2, but D2 and C1 is concatenated. And then here U3, okay, so you will be getting the final sample. So that is done, and then activation of sigmoid is done. Only one class you want to predict, and the number of values you will be getting is going to be the number of classes again. So this upsamples and gives you a result, so that your output will be an image. So we will run it. So this is our model. So there is a matrix which is called as intersection over union. Okay, so this is something like, for example, we are preferring intersection over union. Union is something like entirely combined. Intersection is two things like A and B. If you have Venn diagrams and all, you know, right? So when they intersect, that is intersection. We want the intersection to be more, and we are focusing more on that over union, on the training image and testing image as well. So it's a metric which will tell you how this model is improving. So that's going to be the loss function as well here. So the loss is binary cross entropy, matrix is intersection over union, and optimizer is Adam. So first, with this randomly initialized model, we are going to make a prediction and look at it. So when we run this, it is going to make a sample prediction and show us that prediction for us. Okay, so actually this is the original image input road. So this is the original output which we are expecting, but this is an untrained model, and that's why the results are something like this. So now what we are going to do is we are going to train it. Okay, so it has trained for nearly 200 epoch, and the callback is something like every time it will show the image, every time it will make an inference and show you the output and then vanish. Okay, so when we train this particular thing, let us wait and see one by one. It will be training. So we are approximately running for 200 epoch, and we have the trained model file as well, which we will be using for inference now on a video. Let me show you guys there. We need to check whether it is avoiding the cars and whether it is able to capture the road alone or not. That's what we will be interested in looking at. So let the training goes. In the meantime, okay, in 1 minute, here the training has been started. So the training actually goes a lot of time, and then once the training is completed, you can make an inference like this. Like finally save your trained.h5 file. You can load the model and get the other parameters. What we are trying to do here is we are trying to get an output which is going to be like we get the particular mask, which is that output which we get, and then only the path we are going to highlight in the original image as well, so that in our lane itself we can see what is the path it is actually suggesting. So we are going to weighted image, we are going to just add weighted, so that the original frame along with this highlighted area will be available for us. So we do some pre-processing, and then the image has been predicted by the model to predict, and then it has been combined together. So this will return the final image. So maybe I can reduce this size to somewhat around just cut it off to 2 divided by 2. And then we are just opening our earlier video which we have used earlier for lane detection using OpenCV. We take that video, we are going to process the frame by this function which will predict and give us the result, which is added over it, overlapped, and now we'll see the result. So let me run the Python file. Okay, so this is the result looks like. So this is the weighted combination which your video, the predicted path has been added. As you can see, it is segmenting the road. As well as one good thing is we all want to look at this part. See here, when I look at this video, okay, so this video 4 I have, right? See here. So this video 4 actually, when you look at the place where at around 10 second, okay, so you can see there is a car coming, right? So at 7 second and all, there is a vehicle which is crossing, and now we are running this video and we want to check whether the model is overlapping that as well or it is ignoring that car and give us the original path alone. So that's what our task to look at, and it will run slowly because this laptop don't have GPU. It is not that for mainly for inference, but still it is doing frame by frame, so it will take few seconds. This 7 seconds may be available for you after some time. So this is the original one. So let us see frame by frame. I hope you can see this. It's slow, but still if you want it to be smooth, you can save or export this as a video and then view it. Okay, so now we are interested in that particular frame where a car will be coming, and we want to see whether this blue color highlighted path pass through it or give way for it and only detects the road. As you can see, it is not detecting the trees and all, not the sky, only the road, with some places at the edge is going to somewhere else, right? And you can further fine tune to detect only one area, no, only this particular lane and all. You have to further fine tune. So this is how we do image segmentation. It's used in a lot of places, also for driving cars. So as you can see, by that end you are able to see a particular car is incoming, right? So vehicle, small portion is now visible. So when we go nearer to that car, the model actually gives way. As you can see now the car area hasn't been segmented. Can you see it? The car, it has been given way. You can see that that place hasn't been segmented. At this particular frame, it has been left way, which means it is only segmenting the road. Can you guys see it? Can you guys see how it actually greatly works? So this further fine tuning can be used. Okay, as you can see, still there are some places where you want to further fine tune this. So it is going to you can give a region of interest in that particular place alone, and then you can go, like for example, it is by far and it is detecting the sky and all, because it is a 3D platform, the road is, but the image is 2D, and our model is trying to understand that particular scenarios, right? So this is how we do it. But this model, you can't just take this trained model as well, run it on your Jetson. Memory issue will be available for you, out of memory for GPU will be available for you. So you can actually optimize our model furthermore, make it efficient. Okay, so this optimization is an important part, and that's going to be the topic of next session. So I hope today's session was interesting. We'll see in the next session. Thank you all. So still you can convert the masterclass into 1 month certified internship on NVIDIA with AI, and when you join you will be getting 1 month internship, 30-day PPTs, exclusive project codes for download, VIP community group for doubts and internship updates, IETE confirmation letter, 90 days of LMS course access, assignments and tasks, weekly live sessions, resume building and mock tests, internship and participation certificate. All these things you could get it at a discounted fee at just 999. A registration link is posted in chat box, available in description, and batch 3 ends on 3rd. So 2 days is left. Tomorrow it will be ending. So if you guys are interested, you could get all the benefits, dataset, code files, downloadables, Linux links and all. Thank you all. We'll see you tomorrow. Thank you.